Question 1. By evaluating the airflow behavior in an ISO Class 5 cleanroom, which of the following operational decisions would most effectively reduce the risk of cross-contamination during aseptic processing near a biosafety cabinet? A. Installing a pre-filter upstream of the HEPA filter to catch larger particles before reaching the cabinet. B. Increasing supply air velocity to enhance the rate of dilution of contaminants. C. Orienting the workbench to be perpendicular to unidirectional airflow to maximize coverage. D. Implementing laminar flow hoods with vertical downflow to create a sweeping air curtain. Answer. Correct answer. D. Explanation. In ISO Class 5 cleanrooms, particularly during aseptic processing, vertical laminar airflow, unidirectional downflow is crucial to maintaining cleanliness by sweeping contaminants away from critical zones. Option D provides optimal downward airflow, minimizing turbulence and preventing cross-contamination. Option is standard practice but does not directly affect airflow dynamics within the biosafety cabinet. Option B can cause turbulence, which increases particle resuspension. Option C contradicts airflow design principles. As per ISO 14644-3 in US, by maintaining laminar flow and minimizing disruption is key in high-class cleanrooms. Question 2. As demonstrated by an incident during the quarterly filter integrity test, a technician named Priya notices a rapid pressure drop across the HEPA filter in Zone 2 of a microelectronics cleanroom. What should be the technician's first action to preserve cleanroom compliance and safety? A. Temporarily increase fan speed to compensate for pressure loss. B. Immediately replace the HEPA filter without further testing. C. Initiate a smoke aerosol challenge test to determine the breach location. D. Seal off Zone 2 and continue operations in adjacent zones. Answer. Correct answer. C. Explanation. A rapid pressure drop suggests a possible HEPA filter breach or plenum leak. Option C aligns with ISO 14644-3 Annex B.6, which mandates a challenge aerosol test, e.g. power dot, to identify leaks. Immediate replacement, option B, could disrupt operations without confirming the issue. Increasing fan speed, option A, risk system instability and particle migration. Zone isolation, option D, does not address the contamination risk. The filter must be tested and verified before any further action. Proper leak testing ensures compliance with ISO 14644 validation procedures. Question 3. The underlying principle of effective gowning procedures in ISO Class 7 cleanrooms relies heavily on which factor contributing most to particle reduction during human entry. A. Double gloves to ensure sterility. B. Sequential gowning zones from dirtiest to cleanest. C. Wearing boot covers after donning the hood. D. Positive pressure airlocks to maintain flow. Answer. Correct answer. B. Explanation. Cleanroom gowning must follow a defined sequence progressing from less clean to cleaner areas, minimizing contamination introduction. Option B aligns with ISO 14644-5 and E.C, which emphasize zoned gowning for optimal contamination control. Double gloves are important for sterile fields but don't reduce overall particle load. Boot covers after hood C violates sequence protocols. Positive pressure D supports barrier integrity but doesn't address gowning efficiency. Adherence to zoned gowning reduces human-borne contamination. The primary cleanroom threat. Question 4. When evaluating the merits of airflow patterns in semiconductor cleanrooms, which of the following design flaws would most likely result in turbulence and increased particle deposition on wafers? A. Installing ceiling-mounted HEPA filters with full coverage laminar panels. B. Using raised perforated floors for airflow return pathways. C. Placing process equipment directly beneath HEPA filter outlets. D. Introducing large equipment perpendicular to the airflow path. Answer. Correct answer. D. Explanation. Obstructing unidirectional airflow with large equipment perpendicular to the flow path causes turbulence and eddies, which increase particle settlement on sensitive surfaces. ISO 14644 recommends avoiding disruptions to airflow. Option A promotes laminar flow. Option B is a standard airflow return method in vertical flow cleanrooms. Option C, while suboptimal, still maintains airflow consistency if properly managed. The E.C provides guidance on equipment arrangement to preserve airflow integrity in semiconductor-grade environments. Question 5. In light of recent developments, Raj, the technician working with biological cleanrooms, notices differential pressure dropping below acceptable limits between ISO Class 6 and Class 8 zones. What is the most likely cause and best corrective action? A. Exhaust fan failure. Initiate pressure equalization. B. L-up door left ajar. Immediately close and retest. C. Temperature fluctuation. Adjust thermostat. D. HVAC compressor cycling it. Reduce cycle intervals. Answer. Correct answer. B. Explanation. Maintaining pressure differentials between cleanroom zones, typically 5-1-5 par, is critical to prevent reverse contamination. A door left open is a common and immediate cause of pressure loss. ISO 146444 and ASHRAE cleanroom guidelines stress door management and automated interlocks to avoid breaches. An exhaust failure A would typically increase pressure, not reduce it. Temperature fluctuations C may affect comfort but not pressure significantly. Compressor cycling D impacts cooling but rarely causes abrupt pressure drops. Question 6. What factors contribute to a cleanroom's HEPA filter reaching premature failure or clogging within 3 months of installation, despite normal airflow and particle count levels? A. High outside air humidity causing microbial growth. B. Improper pre-filter maintenance and bypass leakage. C. Overuse of ULPA filters instead of HEPA filters. D. Increased supply fan velocity to compensate pressure. Answer. Correct answer. B. Explanation. Pre-filter failure or bypass leakage allows large particles to load the HEPA filter prematurely. HEPA filters are not designed for high particle loads. As per ESTOP EC and ISO 29463, multi-stage filtration is necessary to protect HEPA longevity. High humidity A may cause mold, but not usually within 3 months. ULPA filters C offer finer filtration but would fail for the same reason if unprotected. Increased fan speed D may reduce lifespan but not as critically as bypass contamination. Question 7. During the process of balancing the cleanroom HVACR system, technician Alina finds that the room meets ISO Class 7 particle counts but fails pressure differential specs. What adjustments should be prioritized first? A. Increase return air volume to balance flow. B. Adjust exhaust damper to increase back pressure. C. Reduce supply airflow rate to match exhaust. D. Increase supply airflow to restore positive pressure. Answer. Correct answer. D. Explanation. Cleanrooms rely on positive pressure to prevent contamination ingress per ISO 146444. If pressure is low but particle counts are within limits, the likely cause is insufficient supply airflow. Increasing air. Option D helps restore pressure balance. Option A may worsen pressure by pulling more air out. Option B increases back pressure but risks disrupting flow balance. Reducing supply C would further drop pressure. Pressure relationships are as important as particle counts in cleanroom classification compliance. Question 8. While it is true that all cleanroom airs must maintain tight control over temperature and humidity, what is the primary risk associated with oversizing an R24? A cleanroom operating at ISO Class 6 standards. A. Reduced filter efficiency due to slower airflow. B. Inability to modulate outside air intake. C. Increased particulate resuspension from turbulence. D. Lower system static pressure leading to filter bypass. Answer. Correct answer. C. Explanation. Oversizing air leads to high airflow rates that disrupt laminar flow, causing turbulence and particle resuspension, especially detrimental in ISO Class 6 environments. As per ASHRAE Cleanroom Design Manual, proper sizing is critical to avoid non-unidirectional patterns. Filter efficiency A is largely independent of flow speed within rated parameters. Outside air modulation B is controls issue, size related. Lower static pressure D results more from undersizing than oversizing. System performance must align with cleanroom airflow velocity standards. Question 9. The most significant aspect of controlling contamination in cleanrooms lies in understanding which common material handling mistake introduces high particulate levels into an ISO Class 7 zone. A. Using electrostatic discharge bags inside the cleanroom. B. Failing to wipe down tools with EPA before entry. C. Transporting sealed, pre-cleaned materials in plastic totes. D. allowing short dwell times in material pass-through. Answer. Correct answer. B. Explanation. Failing to clean tools with isopropyl alcohol EPO before entry allows particles and microbes to enter. According to EC, all non-sterile items must be cleaned and logged to reduce contamination. Test bags A are designed for cleanroom use. Properly sealed totes C prevent contamination. Short dwell times D are undesirable but less impactful than dirty tool entry. Material transfer protocols are critical, especially for zones ISO Class 7 and higher. Question 10. In a modern context of pharmaceutical cleanroom compliance, technician Omar is calibrating particle counters for a routine environmental monitoring test. Which factor is most critical for ensuring accurate ISO classification results? A. Using counters with a minimum flow rate of 25 L/minute. B. Placing sensors near return air grills. C. Calibrating equipment with Class 1 traceable standards. D. Operating counters only during shift breaks to avoid human error. Answer. Correct answer. C. Explanation. Calibration to traceable Class 1 standards ensures data accuracy and compliance with ISO 21501. 4. Proper calibration affects particle sizing counting and thus classification under ISO 146441. Flow rate A should meet the spec, but traceable calibration is more critical. Location near return grills. B. Skews data. Operating during breaks. D. Defeats the purpose of environmental monitoring, which must reflect real-time activity. Valid data collection underpins regulatory documentation and process control. Question 11. From a practical standpoint, when reviewing the pressure monitoring logs for a pharmaceutical cleanroom, technician Lisa notices a consistent drop of 4 part during shift changes. Which approach is most effective in maintaining pressure stability without violating ISO 14644 standards? A. Increase air changes per hour during peak operation times. B. Install a pressure cascade system to adjust automatically. C. Instruct operators to limit door use during changeovers. D. Rebalance exhaust dampers to maintain negative pressure. Answer. Correct answer. B. Explanation. Pressure cascade systems allow automated pressure adjustments between zones, ensuring that ISO recommended pressure differentials, typically equals 5 par, are preserved during shifts. Shift changes increase traffic and door openings, destabilizing pressure. Option may help but doesn't directly stabilize transitions. Option C is helpful but not sustainable long-term. Option D introduces negative pressure, which is contraindicated in most clean zones. Positive pressure preferred. ISO 14644 and HMP X1 both stress active monitoring and automated control for critical pressure parameters. Question 12. To illustrate this point, technician Marco is inspecting ductwork in a cleanroom where particle levels have unexpectedly increased near the ceiling diffusers. What is the most likely cause and what corrective action should he prioritize? A. Supply air has inadequate prefiltration, allowing particles from ambient air. B. HEPA filters were installed incorrectly, allowing bypass airflow. C. Turbulent flow is being caused by obstructions at floor level. D. Differential pressure across the cleanroom envelope is too low. Answer. Correct answer. B. Explanation. Incorrectly installed HEPA filters can result in air bypass, allowing unfiltered air to enter the cleanroom, especially near diffusers. According to EC.6 and ISO 14644. 3. Filters must be seated and gasketed properly. Prefiltration issues A. would affect entire system, not just diffuser zones. Turbulent floor flow C. would not impact ceiling particle concentrations. Differential pressure D. allows ingress from other zones, not internal ceiling issues. Filter integrity is key to point of entry contamination control. Question 13. Among the various causes of cleanroom contamination, which equipment maintenance oversight is most likely to result in increased microbial counts in an ISO Class 8 cleanroom supporting biopharmaceutical packaging? A. Failing to calibrate temperature sensors annually. B. Using lubricants in motorized equipment that are non-cleanroom rated. C. Neglecting to balance air return pathways quarterly. D. Not replacing HEPA filters on a time-based schedule. Answer. Correct answer. B. Explanation. Using non-cleanroom rated lubricants can introduce microbial and chemical contaminants in biopharma cleanrooms. Only FDA compliant, low outgassing, sterorated lubricants are acceptable. Temperature sensor calibration. They affect monitoring but not microbial risk directly. Air balancing. C. Affects pressure and airflow but not typically microbes. HEPA filters. D. Are replaced based on pressure drop or failure, not just time. Reference ISO 14698 USB and EMP guidance or emphasize equipment compatibility with clean environments. Question 14. Through careful analysis of filter loading trends, technician Anita observes that the pre-filters are clogging every 6 weeks instead of the expected 3-month interval. Which root cause should she investigate first to maintain proper airflow rates and filter life expectancy? A. Excessive door openings during peak operation periods. B. Lack of positive pressurization causing backflow. C. Increased particulate generation from process materials. D. System overcooling causing condensation on filters. Answer. Correct answer. C. Explanation. A sudden change in particulate generation, often from new materials or increased process load, can overload pre-filters. ASHRAE 52.2 and ISO 16890 recommend monitoring source-related loading rates. Door openings. A. Might allow some intrusion but would impact HEPA more. Backflow. B. Could cause contamination but not necessarily pre-filter clogging. Condensation. D. Risks microbial growth but isn't clogging mechanism. Addressing material compatibility and source control is the correct path. Question 15. In what ways can improper use of a biological safety cabinet BSC Cleanroom during media prep in an ISO Class 6 cleanroom affect airflow integrity and operator protection? A. It will increase HEPA filter airflow velocity beyond safe limits. B. The BSC will recirculate contaminated air into the room. C. It will disrupt temperature stratification, causing condensation. D. The BSC may overpressurize and damage ductwork. Answer. Correct answer. B. Explanation. A Cleanroom 2 of a ESC recirculates 70% of air internally and exhausts 30% back to the room, which is problematic in high-class cleanrooms where recirculation of contaminated air is not acceptable. According to NS Fancy 49 EAL Idolized, these ESCs are not ideal in rooms requiring absolute contamination control. Filter velocity A is regulated in and not exceeded through normal use. Temperature stratification C is unrelated. Overpressurization D is highly unlikely in properly installed ESCs. Question 16. Based on the information collected from a recent audit, a cleanroom facility using unidirectional airflow failed to meet ISO 14644 1 particle count limits despite proper air change rates. What is the most plausible operational flaw? A. Incorrect placement of particle counters relative to airflow direction. B. Unsealed ceiling panels allowing plenum contamination. D. HVAC coils causing condensation near critical zones. D. Process operators working too close to filter outlets. Answer. Correct answer. D. Explanation. Working too close to unidirectional airflow outlets disrupts the laminar flow and causes turbulence, resulting in particle accumulation in critical zones. ISO 14644-1 and E-Stop EC.2 recommend avoiding interference with airflow path. Counter placement A. Affects measurement accuracy but not performance. Unsealed panels B. Would affect pressure, not directly particle counts. Condensation from coils C. Could cause microbial contamination but is, unlike it, a primary source of particulates unless improperly drained. Question 17. Considering the evidence from a recent system audit, technician Joseph finds that an ultra-clean ISO Class 4 area is exhibiting unexpected electrostatic discharges. What HVAC-related solutions should be prioritized to correct the issue? A. Increase supply air temperature to reduce static buildup. B. Introduce active ionization into the supply airstream. C. Replace all ULPA filters with conductive filter media. D. Raise room relative humidity above 75%. Answer. Correct answer. B. Explanation. Ionization systems help neutralize electrostatic charges in ultra-clean environments where EST can damage sensitive electronics. As per ANSYS point 20 and ISO 14644, active ionization is critical in Class 4 and better cleanrooms. Increasing temperature may worsen static. Conductive filters C are not industry standard. Humidity above 75%. D. Microbial growth and violates ASHRAE guidelines. IDLRH for S control is 4060%, not beyond. Question 18. The prevailing attitude toward preventive maintenance in cleanrooms emphasizes which of the following actions as the most effective in reducing system failures and contamination incidents? A. Annual replacement of ductwork insulation. B. Daily visual inspection of operator behavior. C. Scheduled testing of airflow velocity and pressure. D. Real-time BMS alarm monitoring only. Answer. Correct answer. C. Explanation. Scheduled testing of airflow and pressure ensures that cleanroom integrity is maintained proactively. Per ISO 14644-2 and GMP X1, such validation is a cornerstone of contamination control and system reliability. Duct insulation, it doesn't need annual replacement unless damaged. Visual inspection, B, is part of SOPs, not maintenance. Real-time monitoring, D, is valid, but only scheduled validation can ensure system performance remains within specs. Question 19. What would happen if a cleanroom HVACR system maintains ISO Class 6 particulate levels but fails to sustain proper psychrometric balance in terms of temperature and humidity? A. Particle levels will remain unaffected due to laminar flow. B. Condensation will form on surfaces, risking microbial growth. C. HEPA filters will self-dehumidify via pressure cycling. D. Low humidity will increase air density, improving airflow. Answer. Correct answer. B. Explanation. Improper temperature and humidity control can lead to condensation, especially on cold surfaces, which promotes microbial contamination. ISO 14644-4 and ASHRAE Handbook. HVAC applications recommend tight psychrometric control to prevent microbial risks and material degradation. Particles A are only one risk factor. HEPA filters C are passive and don't dehumidify. Low humidity D increases est risk and reduces filtration efficiency, not improve it. Question 20. During the process of tool and material transfer in an ISO Class 7 cleanroom, technician Nora bypasses a material airlock to expedite equipment delivery. What consequence is most aligned with ISO and GMP cleanroom compliance violations? A. Delay in achieving temperature uniformity in the room. B. Immediate triggering of the HVAC system to rebalance. C. Elevated particle counts from unfiltered pathway intrusion. D. Increase in positive pressure due to added equipment volume. Answer. Correct answer. C. Explanation. Bypassing material airlocks breaches the contamination barrier, allowing unfiltered air and particles into the cleanroom. ISO 14644-4 and GMP compliance protocols require airlocks and pass-throughs for materials to ensure controlled transfer. Temperature A and pressure D effects are minimal. The HVAC system B won't instantaneously correct the issue. Such breach can cause compliance audit failure and contamination events. Question 21. When presented with a situation where a cleanroom operator named Daniel reports fogging on windows and reflective surfaces within an ISO Class 6 cleanroom, what should the HVAC technician prioritize during diagnosis? A. Inspect the refrigeration circuit for subcooling conditions. B. Measure dew point and verify humidity control in the AHU. C. Check for electrostatic discharge grounding faults. D. Perform a differential pressure check between adjoining zones. Answer. Correct answer. B. Explanation. Fogging results from dew point exceeding surface temperature indicating poor humidity control. ISO 14644-4 and ASHRAE psychrometric principles emphasize keeping RH within strict limits, usually 4060%, to prevent condensation. Subcooling A may affect core performance but doesn't directly cause fog. S faults C aren't related. Differential pressure D maintains air cleanliness but doesn't control humidity. Humidity sensor or control loop failure may lead to moisture condensing on surfaces, compromising sterility. Question 22. Based on the information from particle trend logs, technician Priya notes increased particle counts every time compressed air is used for cleaning tools. What modifications should be implemented to remain within ISO Class 7 requirements? A. Use filtered nitrogen instead of compressed air. B. Relocate tool cleaning station closer to return air grills. C. Implement an ultrasonic cleaning protocol. D. Fit compressed air lines with inline HEPA-grade filters. Answer. Correct answer. D. Explanation. Compressed air can introduce particulates if not filtered properly. Fitting inline HEPA filters, or at minimum 0.1 micron rated, eliminates this risk. ISO 14644 and GMP when require filtered process gases in cleanroom applications. Nitrogenate may help but isn't necessary. Relocating the station, B, is a workaround, not a root fix. Ultrasonic cleaning, C, is process dependent and not always feasible. Inline filtration ensures compliance without altering workflow. Question 23. The effectiveness of air change rate adjustments in semiconductor cleanrooms is often debated. Which of the following outcomes is most directly affected by decreasing air changes per hour in an ISO Class 5 zone? A. Filter differential pressure decreases, extending filter life. B. Particle deposition on product surfaces increases. C. HVAC energy consumption increases due to longer cycle times. D. Static pressure in adjacent Class 7 rooms increases. Answer. Correct answer. B. Explanation. Lowering it slows down dilution and removal of airborne contaminants, leading to increased particle deposition. Critical in ISO Class 5 where cleanliness is paramount. ISO 14644 mandates specific H values based on classification and process sensitivity. Decreased H doesn't guarantee longer filter life. A. If contamination rises. Energy consumption, C, generally reduces, not increases. Adjacent static pressure, D, is typically unaffected unless fan systems are linked. Contamination control must be prioritized over energy savings in critical zones. Question 24. Under the assumption that a new biological cleanroom is being commissioned, technician Sarah is tasked with validating airflow uniformity. Which method offers the most accurate evaluation according to ISO 14644? 3 guidelines. A. Install manometers at all air diffusers and balance flow. B. Perform a smoke study to visualize directional airflow. C. Use anemometers to create a velocity map across critical zones. D. Conduct a particle count over a 24-hour period at rest. Answer. Correct answer. C. Explanation. To validate airflow uniformity, velocity mapping with anemometers is required. ISO 14644-3 specifies measuring at multiple points, typically a 6-inch grid, to confirm laminar unidirectional flow. Smoke, B, is qualitative, not precise. Anemometers, A, measure pressure, not airflow. Particle counts, D, confirm classification, not airflow behavior. Uniform velocity, plus 20% across the field ensures consistent contaminant removal and process integrity. Question 25. What factors contribute to premature corrosion of metal ductwork in cleanroom HVAC systems, particularly when servicing pharmaceutical or chemical processing zones? A. Overuse of high-efficiency filters restricting airflow. B. BMS controls not calibrated for humidity. C. Use of non-corrosion-resistant metals with reactive chemicals. D. Excessive insulation thickness reducing duct ventilation. Answer. Correct answer. C. Explanation. Exposure to reactive or corrosive chemicals. E.g. cleaning agents. Vaporized hydrogen peroxide in cleanrooms can degrade metal ductwork not built from stainless steel or coated aluminum. ISO 14644 doesn't dictate material, but GMP and ISO 14698 stress compatibility and corrosion resistance. High-efficiency filters, A, protect air, not ducts. BMS calibration, B, affects system control but not directly corrosion. Insulation, D, does not affect ventilation inside ducts. Material compatibility is design prerequisite in aggressive environments. Question 26. To better understand contamination profiles in a Class 100 ISO Class 5, cleanroom technician Jerome compares particle count results during production and at rest What is the significance of increased counts during production, assuming baseline was within limits? A. Indicates airborne contamination from the HVAC return air. B. Confirms that the cleanroom is properly pressurized during operation. C. Suggests personnel or process-related particle generation. D. Implies filter media degradation during dynamic conditions. Answer. Correct answer. C. Explanation. Increased particle counts during operation versus at rest indicate contamination from people, processes, or equipment motion. ISO 14644-1 defines these test conditions specifically to highlight real-world cleanliness challenges. Return air is filtered before recirculation. Pressurization, B, is unrelated to particle activity. Filter degradation, D, would show across both static and dynamic phases. Proper gowning, training, and process review are essential when dynamic contamination exceeds tolerances. Question 27. During the process of preparing the preventive maintenance schedule for a multi-class cleanroom facility, what should technician Layla consider the most critical inspection interval for ULPA filters in ISO Class 3 zones? A. Every 24 months, based on manufacturer guidelines. B. Annually, aligned with ISO 14644-2 requalification. C. After every production batch in critical areas. D. Semi-annually due to elevated pressure environments. Answer. Correct answer. B. Explanation. ISO 14644-2 mandates annual requalification testing for cleanrooms ISO Class 5 and better, which includes filter leak and performance testing. ULPA filters used in ISO Class 3 zones must be validated yearly to ensure particle control. Manufacturers' intervals vary, but ISO takes precedence. Post-batch checks, C, aren't required unless integrity is compromised. Pressure D does not dictate interval unless failure occurs. Documented inspection, testing, and certification are essential for GMP compliance and operational continuity. Question 20. Taking into account the critical nature of gowning areas in cleanroom design, which configuration best supports contamination control between the gowning zone and the classified workspace? A. Open transition with directional airflow arrows only. B. Double door airlock with positive pressure and filtered air. C. Negative pressure vestibule between gowning and workspace. D. Pass through with motion sensor activated airflow. Answer. Correct answer. B. Explanation. A double door airlock with positive pressure and filtered air is standard in ISO 14644-4 and GMP X1 for maintaining separation between gowning and cleanroom. This prevents back contamination and maintains pressure cascades. Open transitions, often no control. Negative pressure vestibules, C, risk pulling particles from dirtier areas. Pass-throughs, D, are for materials, not people. Maintaining pressure gradients and airflow direction is key for zone contamination control. Question 29. In response to increasing reports of pressure fluctuation in an ISO Class 7 HVACR zone, technician Hugo conducts a fan performance test. Which issue would most likely be revealed if fan curve analysis shows unstable static pressure at varying loads? A. Air mixing dampers are stuck in full open position. B. HEPA filters are clogged beyond final resistance. C. Variable frequency drive VFD is malfunctioning. D. Return air plenum is undersized. Answer. Correct answer. C. Explanation. A malfunctioning VFD can cause unstable fan operation, resulting in erratic static pressure under load variation. HVAC systems in cleanrooms must maintain consistent airflow and pressure air modulate fan speed to achieve this. Damaged dampers or filters B cause steady pressure issues, not fluctuation. Undersized return plenums D affect flow rate, not real-time stability. Per ASHRAE guidelines and ISO 14644-4, consistent fan control is essential for pressure integrity. Question 30. Throughout the course of weekly inspections, technician Naomi finds that operators frequently lean over critical work zones during aseptic filling operations in an ISO Class 5 environment. What procedural reinforcement should be implemented to ensure compliance? A. Require triple gloving when working in unidirectional flow zones. B. Introduce automated alarms for airflow interruptions. C. Retrain staff on first air protection and aseptic technique. D. Increase room pressure to enhance vertical airflow. Answer. Correct answer. C. Explanation. Leaning over critical zones breaks first air protection, increasing contamination risk. ISO 146445 and US emphasize operator discipline and aseptic technique training. Triple gloving A does not protect the airflow path. Airflow alarms. B. Help but don't fix behavior. Pressure increases. D. Don't resolve disruption of unidirectional flow. Training ensures operators understand their role in maintaining cleanliness at the point of use.